So today is a block day and I didn't record in class, so I'm just going to do a quick recording. This is the video for the Algebra 1A class either on October 18th or 19th. It would have been the same lesson. We started with this bell work. We did not do, normally we would have done linear graphing by now, so graphing slope-intercept form problems. The new book has us going in a different order, so we have not done that yet. So the bell work was actually set up with the idea that we had already done that. So we really just did the first two bell work problems since we haven't actually graphed. So for the first, actually, I think we did number 2 first. So what does the word evaluate mean? So for the word evaluate, we talked about the fact that in math, evaluating really just means that we're going to solve the problem given the new information that we have. So let me zoom in real quick. So if we have an equation y equals 3x, then we cannot solve for y and x. Now we can come up with different combinations of y and x that will work, but that's not solving. Solving means we come up with really one number that works, one number that will make the left side equal the right side. Well, in this case, there's too many possible combinations. So for example, we could say, well, if I have y, whoops. There we go. If I have y equals 3x, you might say, well, y could be 6 and x could be 2. Because 3 times 2, so 3x means 3 times x. So if I were to replace x with 2, 3 times 2 would equal 6. So those two values make the left side of that equation equal the right side of that equation. But then there's an infinite number of other values that will also make the left side equal the right side. We could say y is 9 and x is 3. We could say y is 3 and x is 1. And we could do that forever. Like I said, there's an infinite number of numbers, infinite possibilities. So we can't solve and just come up with one solution set. We could graph it, but again, we haven't done graphing yet, so I'm not going to spend really any time on that. So what the next piece of this problem says, what does y equal if x is 4? That's where the word evaluate comes in. So if we were to say evaluate y or just evaluate the equation if x is 4 or when x is 4, that would just mean we're going to take the equation that we start with and we're going to say, okay, well, I want to solve for y, I want to evaluate y if the value of x is 4. So y would then equal 3 times 4, because now x would be 4 if I'm saying evaluate it if x is 4. So y would equal 12. So that's all evaluating means. It just means solve by plugging in the new information that they give us. And in this case, the new information is that x equals 4. So with functions, we played a video to start out. And it's a video that I've played for years, found on the internet. But I'm going to stop this off and on, and I'll talk a little bit about what she is saying. The first definition I guess you need is what a relation is. A relation is just a set of data. It's an x and a y value, or really it's a bunch of x and y values in any kind of format. It could be a table. It could be what's called a mapping diagram, which is what you kind of see right here. That's called a mapping diagram. It could just be in a set of ordered pairs, which is just a bunch of x and y values. It could be on a graph, but a relation is just x and y values, inputs and outputs. And I'm going to talk more about this throughout the video. So all sets of x's and y's are relations, but then there's also a special type of situation where it's also called a function. And that's what we're going to talk about in the video. There we go.
It's just something that takes an input value and assigns it to exactly one output. You can kind of think of a function as a vending machine. The input on the vending machine would be the code that you type in, and the output would be the pop or candy or whatever that you chose that comes out of the vending machine. So a function takes an input value.
So in class, I drew on the screen. I can't do that, unfortunately, right now because I'm not in my room with my smartboard. And when I tried to figure out a way to do it, it ruined the recording last time I tried. So I'm just going to talk through it. So again, with this particular comparison, the input would be the button that you punch in to get whatever you want. So you see inside the machine, there's a bunch of trays that have drinks or food or candy or whatever it is. The input is what you punch in to try to get something out. The output would be what's in the tray that you punch and what you get out of the machine. So the input values are going to be the X values when we talk about different relations or different functions. So we always think of the X values as the inputs. The Y values are what you get out. They're the outputs. So for example, in the bell work that we just did, where it was Y equals 3X, the input was the X value of 4. We input 4 into the equation, and the output was what we got for Y, which was 12. So by inputting 4, we got an output of 12. So we're going to do more with numbers in a minute after the video. But again, as she goes through this and as we go through the lesson, I'll kind of use both numbers and the vending machine comparison.
Something in the function, and it gives you something. One very important rule about functions is that a function can only assign one output to an input value. For example, with the vending machine, if I plug in the code D4 and it drops a bag of pretzels, the next time I go to enter the code D4, it has to give me a bag of pretzels. So it can't assign more than one output to an input value. Same thing with C2. If I plug in the code C2 and it gives me chips, the next time I plug in C2, it has to give me a bag of chips again. Remember, in order to be a function, it has to assign exactly one output to each input value. So if you look at the mapping on the left, every input is assigned to only one output. If I enter the code D4, I get pretzels. If I entered the code D5, I also get pretzels. That's okay. That just would be if I had two slots right next to each other in the vending machine and they both had pretzels. That's fine. And then E2, if I enter that code, I get a water bottle. So each input is only assigned to one output. This one on the left is a function. If you look at this part right here, if I entered the code D4, this says that I'll get either pretzels or chips. This means there's something wrong with this vending machine. In order to be a function, if you enter the same code, you should get the same thing every time. So if I enter the code D4, I can only get one thing out. I can't have it be matched up with two different objects. So this one here is not a function because this input value has been assigned to more than one output value.
Okay, so I'm going to explain this with the vending machine example that she just went through, and then we'll have some examples with numbers. So all she's saying is, again, just like a vending machine, over here on the left, it works like a normal vending machine should work. If I look in the vending machine and I'm looking at the different items, I see pretzels are in the D4 slot. If I punch in D4, I should get pretzels. Then in the D5 slot, there might also be pretzels. That is a separate tray. It's a separate output. Even though it's still pretzels, it's okay that we have different items in different trays. The key is, though, I'm pressing a different button when I get those pretzels. So that's fine. I can press two different buttons and still get pretzels. There's no problem with that. And then, of course, I can obviously press a completely different button and get a completely different item in a vending machine. So that should all make sense if you think about a vending machine. Oh, so that would mean this is a function. There is no situation where we push the same button twice and somehow we get two different items. Now over here on the right, this is what she was saying is a broken machine. This machine just doesn't make sense. And that's kind of what you can think of something that just doesn't make sense as not a function. A function makes sense. Something that doesn't make sense is not a function. So for example, if I push D4, these arrows are telling me what I get. So I push D4 and one time I get pretzels. Well, that's fine, no problem yet. But then when I hit D4 again, I should get pretzels. That's what I got before, but I didn't. I somehow got chips when I pushed D4 again. That doesn't make sense. That is a broken vending machine. Something is wrong. So therefore, that is not a function. It doesn't make sense, not a function. So now let's talk about, well, she's going to talk about, I guess, or really I'm going to talk about, she's just going to show you the first screen.
The examples that we just looked at were drawn as mappings, but a function can also be represented as a set of ordered pairs or as a table. So let's look at these two examples to see if we can determine whether they're functions or not. When you have a set of ordered pairs, the x values are always the input values, and the y coordinates are the output values. So this says that when I plug in 0, the output is 1. When I plug in 2, I get 3. When I plug in 4, it assigns it to the 7. And when I plug in 2, the output is 9. So my input values were 0, 2, 4, and 2. Do you see how it has two inputs that are the same? So here's an input of 2 and here's an input of 2. This time when I plugged in 2, it assigned it to 3. And over here, when I used 2 as the input, it assigned it to 9. That's kind of like the vending machine example where it assigned it to two different things in the vending machine, pretzels and chips. And this is a problem. If I plug in 2 as my input value, I need to get out the same exact output value. So since this set of ordered pairs has assigned 2 to two different outputs, this is not a function. If we look over here, this table has assigned 3 to 9. When we plug in -1, we get 7. When we plug in 4, we get 10. And when we plug in 5, we get 9. No input value has been entered more than once, and each one has only been assigned to one y value. So this one is a function. It can be tempting to say that it's not because you see these two 9s here, and that's okay. That's just like if the vending machine had two slots that both gave out pretzels. This is like it has two different values that'll give you 9, and that's okay. That's not a problem as long as every x is only paired with one y. A function can also be shown.
Okay, so we're going to stop the video there. I'm going to take a real quick because this is going to be easier to do in the smart notebooks. Backwards. I'm going to kind of just repeat everything she said, but maybe talk about it in detail. So I guess that's fine. Screenshot real quick. If you've never used this snipping, I don't even know if this is recording, but if you've never used the snipping tool in your computer, it can be very helpful if you ever have a class where you need to take, where it would be helpful to take screenshots. Now I can paste it into any document. It's just an image now. Let's see. Page. All right. So again, with a function talking about numbers now, and I'm going to zoom out. You should be able to see this finally, for sure. So all of these numbers, they're just data. It's a set. When I say a set of ordered pairs, it just means there's different values. They can represent all kinds of data. When I had a job, a lot of times the data that we dealt with might have to do with how many units of something we sold and how much money we got. So the X value might be the number of units, and then the money might be the Y value, the output. So that the money you get is dependent on how much you sell. So that's why X was the input, Y was the output. So again, there's all kinds of data and scenarios where you can have it. So for now, we're just going to talk about X's and the Y's. So I can write this data really in a whole bunch of different formats. So these are different data sets, different relations, I should call them. Relations is the correct word. This is a relation here. The second one is a totally different relation. They're two different problems. But I can change these into any format I want. So for example, in my screen a little bit, if I wanted to take this problem number 1, I could write it in, we're going to say really 3 different formats besides the one that's already in. It's already in a set of ordered pairs. So I have X's and Y's, X's and Y's, X's and Y's. So if you don't remember, X is the first number, Y is the second number. X. And I'm trying to Y, X, Y. First number is always the X, second number is the Y. I could take those ordered pairs though and put them into a table, just like what we're going to do in number 2. I could say, well, really all I'm saying is that my X values are on the left. X's are always on the left. Y's are always on the right. Doesn't matter the way the data is. See there, X is on the left. Y is on the right. If I make a mapping diagram like she was using in her video, X's will be on the left and Y's will be on the right. I'm actually going to do that in a second. So for this table, 0 goes with 1. So that's my first ordered pair. I'm just taking each ordered pair and putting them in a table. 2 goes with 3. 4 goes with 7. And then 2 goes with 9 for the last ordered pair. So there's the table. I just took that data, I put it in a table format. It's the same exact data, it's just in a different format. So I could do the same thing with the table on the right. I could take that and put it into ordered pairs. I could say, well, that's just 3, 9 and -1, 7 and 4, 10 and probably I can write it in here, I guess, and then 5, 9. It's just data, lots of different ways you can put it. The last way, which is what she was using, I could put it in a mapping diagram. Again, X's will be on the left, so I have 0, 2, and then 4. I don't write 2 twice because I'm going to use lines to show that 2 gets used twice. And then I could use 1, 3, 7, and 9. So the 0 goes to the 1. So I would show that with an arrow. The first data set with 2 is 2, 3. 4 goes with 7. But then 2 again comes down here and goes with 9. I'm not sure why my pen's right. You get the point, hopefully. So again, this is not a function because we have the number 2, which is an X value, which repeats. We have the number 2 repeated, and it has 2 different outputs assigned to it. One time we assign a 3 to it, and then one time we assign a 9. That cannot happen. I can use the number 2 again if I want to, but I should always get the same output. I should never get a different output. So if I put the number 2 in again, I should get out the number 3, just like we got here when we got 3 the first time. That would mean it would still be a function. I could also graph these. We haven't done graphing, so I'm not going to put on graph. That's what we're doing next. All right, so This is not a function. The number 2 is used twice, just like she underlines here. And when it gets used a second time, I get a different output. So again, not a function, just like she said. On the right-hand side, I never use any x value twice. I have a 3, a -1, a 4, and then a 5. If you never use an x value twice, it has to be a function because there's never an opportunity for you to assign a different output to the same input. You never used an input twice. If you don't understand that, it'll get clarified over the next class or so. But a shortcut is if you look at all the x values and they are all different, it's automatically a function. There's no way it can't be a function. So again, we're going to talk more about that next class. If I added a row on to this table over here, and if I said, well, what about if I had -1 and then 7? Now, do you think this is a function? I'll let you pause it and think about it. So you should have already paused it. If not, pause it again now because I'm about to give you the answer. So I use the number 3 with 9. I have a function when that happens. I use the number -1 with 7. I'm still at a function as of right here. I'm still at a function because I used 4 with 10. So far, I haven't even repeated an x. Now I use the number 5, the input 5, and I get 9. That's fine. Doesn't matter that I have 2 9s. It doesn't matter at all that my output is the same. It just matters whether or not I have gotten a different output for the same input. Well, I haven't even used the same input yet. So I'm still a function, even though I've had the same output of 9. Now, though, I use this -1 again. So I used it here, and I'm using it again here. So remember the rule, the key. If I use an input more than once, so I used -1 a second time, I can still have a function as long as I have the same output. Well, let's look at the output now. My output is 7. Well, it's the same output. I did not get a different output. So it would be just like I hit the same button on a vending machine and I get the same thing out from the vending machine that I got the first time I used it. That's fine. That's what should happen. You should get the same thing out. So in this case, it is still a function. It's okay to have your x value repeat, like right here. That's okay, as long as you have the same y value, which we do. So same x value, same y value, that is still a function. The only time it is not a function is if you repeat the x, like we did here with the 2, we repeated the input, but we got a different output. That's when it is not a function. Backwards, we did some little assignments in class. I guess maybe I have one on here. We'll do it again in class if you do it. This is really only. So you can tell me in these problems since you don't, this is not what we used in class, but you can tell me, and we haven't done domain and range, so you can come back and do that, or hopefully by then you maybe will have the worksheets from class. Tell me if these are functions or not. So 7 through there. Oh, actually, let's try to get all of it. Well, there you go. You see 13, 14, and 15. You're supposed to be doing domain and range. So for 7 through 15, I want you to tell me, is it a function or not? What is the domain and what is the range? And I'm going to do domain and range in a second. Tell you how to do that. I'm not going to go over these. You will go over these eventually in class, so I'm not going to go over them in the video. But if you want to try those really quickly, I guess I can tell you. Number 7 is a function. Number 8 is not a function. Number 9 is a function. Number 10 is a function. Number 11 is a function. Most of them are functions. Number 12 is not a function. Number 13 is a function. Number 14 is not a function. And number 15 is a function. So let's talk about domain and range. All right, so here, oh wait, that's not what I wanted. Oh, I didn't really do my domain. I'm sorry, my function machine, but that's okay. So for domain and range, the first thing you have to know is that the X values are where the domain comes from, and the Y values are where the range comes from. So that's the first thing you need to understand. Once you understand that, the rules for domain, for creating the domain and the range from a set of values are the exact same, other than the X and the Y thing. You write them down in order from smallest to largest. So that's this first one. And then the second one is do not repeat any values. So some sets of data, you may have the same X that shows multiple times or the same Y that shows the multiple times. You don't write them multiple times when you write the domain and range. And I'm going to give you an example in a second. So for example, if we were to write the domain and range for this problem number 1, the domain, we said, comes from the X values. So I write all of the values, all of the X values in order from smallest to largest. Well, I have a 0, that's my smallest X. I have a 2. I do not write the second 2 because that was rule number 2. Don't write anything twice. And then I have a 4. So that's the domain. That's all there is to it. Write all of the X values in order from smallest to largest and do not repeat anything. The range comes from the Y values. And oh, and normally you'd see this in brackets, something like this. Those are horrible brackets, but you'll see it in class if you just missed the particular day of this lesson. So I would write all of the Y values in order from smallest to largest. They're really already in order from smallest to largest. So that's my range. Oh, that's a really horrible bracket. So brackets are supposed to look like that. So, God, I can't write with this pen. This pen's horrible. So anyway, there's your domain and your range for number 1. For number 2, again, I take all the X values. There are no repeated values, so I don't have to worry about that. I just have to make sure they're in order, smallest to largest. So domain be -1. Be careful on your negatives. I'll show you what I showed in class, and people have already made mistakes, even though I made a big deal out of it. So there's your domain. Your range would be all of the numbers in order, but do not repeat 1, which we do have a 9 that repeats, so I do not repeat that. So there's your range. Again, make sure you wrote this rule down, both of the rules. Number 1, write them in order. So that was rule number 1. Number 2, do not repeat any of them. People have already messed these up. It sounds like a simple thing. Just be very careful. You have to follow those rules when I ask you to tell me what the domain is and what the range is. We haven't done that yet, so we'll come back to it. We haven't done that. So again, now if you want to try to do the domain and the range, some of these are super, super easy. They're already in order from smallest to largest. Some of them are not. Oh, when you're putting stuff in order from smallest to largest, think of a number line just to make sure that you get everything in order. If 0 is in the middle, the negative numbers go out like this: -1, -2, 3, -4. So the farther left the number is, the smaller the number is. Obviously, the farther right the number is, the larger it is. I don't think those are typically difficult to put. So for example, the number, if we were doing, let's say, problem 11, -9 is a smaller number than -4. Because here's -4 on a number line. -9 would be like way out here somewhere, actually even farther out than that, really. -9 would be way to the left of -4. So again, the farther left it is, the smaller it is. So if you need to use that when you have a bunch of negatives and you're a little confused about which one is smaller and which one is larger, think of a number line. The farther left it is, the smaller it is. The farther right it is, the bigger it is. And I believe that's all we've done. If you want, don't worry about the one-to-one thing. We haven't covered that yet. You should be able to do domain and range for that though, and you should be able to tell me if it's a function or not. You could do the same thing if you want for B. I'm just trying to give you guys some extra problems if you missed class and you didn't have the papers to try to do. You could tell me domain, range, is that a function or not right there? We haven't done graphing yet, so you wouldn't know that. Are there any other problems you could do? There's some more 16 through 18 you could do if you want to tell me a domain range, whether or not it's a function. We haven't done that yet. There's a couple more you could do. You can tell me, is it a function? What's the domain and range? Mapping diagrams are typically already in domain and range order. So if you notice, those are already in order, smallest to largest. Nothing repeats. So that is your domain. These are already in order, smallest to largest. Nothing repeats. So that is your range. So you don't really have to worry about it normally when you have a mapping diagram like that. I think that might be, oh no, there's something. Oh, here's a summary. I'll show you that real quick. So there's just a summary of what a relation is, what a function is, how to do the domain and the range. We'll do graph next. Oh, and then there's the problems, but that was the old book though, so that might help you any. All right, so I think that's everything that we covered on the 18th and 19th.